Hello everyone, this is Ms. Saturian here again, and we'll be diving deeper into graphs today, and we'll be looking at a specific type of graph, distance time graphs. Our essential question for the day is, how does the shape of a distance time graph describe the motion of an object? A distance time graph can tell you a whole lot about how an object actually moves. It could tell you the direction that the object is moving, whether it's going forward or backwards. It could tell you the velocity at which the object is moving. It could give you information about short and long distances that the object covers and times of motion. And it could tell you an object's location at any time in a specific time interval. The slope of the line in a distance time graph can help you understand the direction the object is moving, either forward or backward. If a line has a positive slope, then the y value always increases when x increases. A positive slope on a distance time graph indicates positive velocity, which means the object is moving forward, just like the orange car in this graph. So if you look at the x and y values closely at each second on the orange line, every time x increases, so does y. So if you look at, let's say, 1 second on the orange line for the orange car, the object has moved 1 meter. At 2 seconds, it's moved 2 meters. At 3 seconds, 3 meters. And 4 meters. So as the x is increasing, the y is increasing. Again, this means that it's a positive slope and that the object is moving forward. Now, let's look at the blue car. This line has a negative slope, which means that the y is always decreasing when the x is increasing. A negative slope on a distance time graph indicates negative velocity, which means that the object is moving backwards, just like the blue car in this graph. So let's look at the numbers again. At 1 second, the object has moved 4 meters. At 2 seconds, the blue car has moved 3 meters. At 3 seconds, it's moved 3 meters. And at 4 seconds, it's moved 1 meter. And so you can see that the y value keeps decreasing as the x value increases, which means this is a negative slope and the object is moving backwards. A distance time graph can also show how quickly an object is moving compared to another. Is it moving faster or slower than another object? This again can be determined by looking at the slope or steepness of a line on a graph. Let's look at a couple of examples. Here we have 3 boats, a red boat, a green boat, and a purple boat. We'll worry about the purple boat in a minute. The greater the slope of the line, the steeper the line is. So if you compare the lines for the green and red boat, the green boat has a line with the steepest slope. Now, what exactly does that mean? So this indicates that the green boat is covering a greater distance in a certain amount of time compared to the red boat. Let's look a little closer. At 2 seconds, the green boat has gone a distance of 4 meters compared to the red boat going just 2 meters. So a steeper line on a distance time graph means the object is moving at a faster velocity because it's covering more distance in the same amount of time. Now, how about that purple boat? Do you notice that time keeps going on, but the distance doesn't go up or down? This means that the boat isn't moving. Perhaps it's taking a break, or it ran out of gas, or it's just fishing. The boat is just stopped. Now, let's put the last few slides all together now in review. This graph shows you the distance a pink motorcycle goes in a certain amount of time. Or you could think of it as the velocity of a pink motorcycle. So at this point, it's the starting time and the location that the motorcycle has started at. So we're at 0 seconds, and the object has already gone about 5 meters. Then you've got this gradual positive slope going up from about 0 seconds to about 7 seconds. This is a slow forward movement of the pink motorcycle. The next place you get to is the one with the horizontal straight line. Remember, that's an object that stopped. And you could see it's a short amount of time. It's about 1 second, from 7 to 8 seconds. Then you've got this negative slope next that goes from about 8 to 10 seconds, which means the object is moving backwards and at a faster pace because you have a steeper slope. And then we've got one more. That's our ending time and the location that they stopped at, which was at 2 meters. So to summarize, let's review our essential question. Again, you can use this question to help you create a summary for your notes. How does the shape of a distance time graph describe the motion of an object? Thanks for watching.